Alright, in this video we're going to go through the January 2013 Regents, doing questions 6 through 10. So if we look at number 6, it says, in which type of chemical reaction do one or more reactants combine to form one product only? So this goes back to the reaction types that we talked about back in the middle of the year. So if we look through what all of these types are, synthesis, remember, is any time that we have something plus another thing combining to make a new thing. So essentially we're taking two things and combining into one. So this is actually going to be the answer here, is synthesis. Decomposition, we said, is one thing breaking up into two things. So it could be, let's say, AB breaking up into A plus B. Single replacement, what we had was AB plus C making. So basically, single replacement, we have one replacement, just like the name would imply. So C could come in here and replace A and become part of this compound with B, making it CB, and kind of kick off A on its own, so it'd be CB plus A. And then with double replacement, what we'd have is AB plus CD making, and double replacement, we have two switches here, so this is going to be C and A switching, and this would make CB plus AD. So these are the four reaction types. I'll put a link in the video as to which video you could go check out. The reaction types video from the bonding unit, from the formulas and equations unit, excuse me, to kind of review these reaction types because you should know them in pretty good detail. Alright, if we look at number 7 here, which why is neon a group 18 element? So neon is a gas at STP. That does not explain why neon is group 18, because there's a bunch of elements that are not in group 18, such as fluorine, chlorine, that are gases at room temperature at STP that are not in group 18. So that doesn't explain why it is. Neon has a low melting point. That also doesn't explain it, because lots of things have low melting points that are not group 18. For 3, though, it says neon atoms have a stable valence electron configuration. So this is the answer, because if we look at group 18 here, this is the noble gases. Sorry, just give me a sec. The noble gases here in group 18, and they have a stable electron configuration. Remember, we talked about the octet rule, right? So group 18 here has this full octet in the valence shell. Neon is one of those, so that's why it's a group 18 element, is because it has 8 valence electrons. That's what defines a group, is how many electrons it has. So neon has 8 valence electrons, just like all of these noble gases here. So, sorry about that. So if we look at number 4 as well, neon has 2 electrons in the first shell. That doesn't really mean anything. Everything has 2 electrons in the first shell as long as it's past helium on the periodic table. So the answer here again is 3, because it's a noble gas. It has that full octet of 8 valence electrons. That's what's going to make the answer number 3. So for number 8, which element has chemical properties that are most similar to the chemical properties of fluorine? This is another time we're just going to look at the periodic table and see, okay, fluorine is in the same group as the halogens, chlorine, bromine, iodine. Anything that's in the same group is going to behave similarly, so we just want to choose a halogen as our answer here. And if we look at the answer choices, we have chlorine here, which is a halogen, so it's going to be our answer choice. Again, anything that's in the same group has the same number of valence electrons. Those valence electrons are the ones that mainly determine reactivity. So things that have the same number of valence electrons are going to behave similarly, have similar chemical properties, and these are again things that are in the same group. So chlorine would be the correct answer here. For 9, what occurs as 2 atoms of fluorine combine to become a molecule of fluorine? So remember, you gotta know the definitions of atom and molecule here. So atom is just one fluorine with however many protons and electrons it has. That would be 9. So a molecule would be, remember we said fluorine is diatomic here, F2 as a molecule. So F would be an atom of fluorine, and F2 would be a molecule of fluorine. It's a diatomic molecule. So here we would have a diatomic fluorine molecule. So as we form this molecule from two of these fluorine atoms, what happens? Well, we have to have a bond between these molecules. If we draw a Lewis structure here, it would be fluorine bonded to fluorine, right? We could draw in all the lone pairs, but we need some bond connecting these two fluorine atoms. So a bond is not broken when we form this molecule. A bond has to be formed. And whenever we form a bond, that's going to release energy. This is a favorable process that's going to release energy whenever you form a bond. If you break a bond, that requires energy, because this bond is holding these two atoms together. You have to give it some sort of energy to break that bond. But in this case, we're going from atoms to a molecule. We're forming a bond. In that case, energy is going to be released. Forming bonds is always exothermic. So that would be answer choice 2 here. And then looking at number 10, what is the number of pairs of electrons that are shared between the nitrogen atoms in a molecule of N2? So again, this is a diatomic molecule. This goes back to drawing Lewis structures. So if we have N2, that's going to be N bonded to N. So let's say we try and do a single bond here. Remember, when we're doing the Lewis structures, we need to count up our valence electrons. Nitrogen has 5 valence electrons. So 5 plus 5 means we have 10 total electrons here. So if we have 10 electrons and we bond them together, we've used up 2. So what you might think to do is maybe do something like this. This gives us 2, 4, 6, 8, 10 electrons used up. But what's the problem with this Lewis structure? We always need to follow the octet rule. So right now, if we count the electrons around this nitrogen, we have 2, 4, and 6 total around this nitrogen here. So that's not satisfying the octet rule. In this nitrogen, same thing. It has 6 total electrons, because remember we have 2 electrons in this bond. So neither of these would be satisfying the octet rule right now. So what's a better way that we might be able to do this? Well, if we try and make a double bond, and we've used up 4 of our 10, we have 6 electrons left. We could do, let's say, 2, 4, 6. We're still not satisfying the octet rule here. This nitrogen is happy. It has the octet, right? 2, 4 valence electrons and 4 in the bond, or sorry, 4 lone pair electrons and 4 in the bonding sites. But this nitrogen, it has 4 electrons here from this double bond and 2 electrons here. It only has 6 electrons total, so it is not satisfying the octet rule right now. So the best Lewis structure that you can come up with here is a triple bond here with 2 lone pairs, 1 on each nitrogen. So if we count up the electrons here, we have 2 plus 6 plus 2, making 10, which satisfies the 10 valence electrons that we needed here. So how many, going back to the original question, the number of pairs of electrons that are shared, so each bond is 1 pair of electrons. We have 2 electrons shared in each bond. We have 3 bonds in this triple bond, so 3 bonds times 2 electrons per bond would give us 6 electrons shared total. But the question is, how many pairs of electrons are shared? So there's 3 pairs. We have 1, 2, 3 bonds here. And I'm going to take those dots out because that's probably going to be confusing. But we have 3 bonds here. Each one of those is a pair of electrons, so we have 3 pairs of electrons total. Alright, next video will be questions 11 through 15. Thanks for watching.